Okay, so you're a data scientist or you're a machine learning engineer and you are trying to prepare your data for model training. And you look at your data and you see that, oh, there are many, many more columns than the rows. There are many, many more features than the rows. This means you potentially have an underdetermined system. That means you have infinitely many solutions. Okay? So what do you do then? One solution to that is to do dimensionality reduction. That is to use some kind of regularization or principal components analysis to reduce the number of dimensions. Okay, so that's the first step, is do you have a data set that has more columns than rows? So how do you think about processing the data? It is underdetermined. I probably need to regularize. I probably need to reduce the dimensions. What about an overdetermined system? That is if you have more rows than columns. You have more examples, you have more observations than features. You have a rectangle that's shaped like this, right? It's a lengthways going vertically. What do you do then? That is an overdetermined system. There you have no solution. So what do? You use a least squares method like linear regression or even neural networks, some kind of optimization method to find a solution. So I want to recap. You need to know linear algebra if you want to go into machine learning. So you look at your data set. Does it have more columns than rows? Then that is underdetermined. Does it have less columns than rows? That is overdetermined. Underdetermined systems, what can you do? Reduce the dimensions using regularization or PCA, something like that. What do you do for an overdetermined system that has no solution? You minimize the error. You optimize using something like least squares. So try that and learn linear algebra if you want to go into machine learning.